Hello and welcome to this session for real-time analytics on the Oracle Data Platform. My name is Halldin, and I'm an analytical data platform design specialist. Data is changing the way businesses are being built and run. Most business leaders will agree that future success is increasingly reliant on their ability to turn real-time data into a differentiating advantage. A key requirement to get more value from real-time data is to foster an analytics-driven culture with real-time data, streaming processing, machine learning, and AI. Many of us has a notation of what real-time means. But when it comes to defining the term, the definition may differ. Real-time is defined by requirements of maximum tolerance or deadlines of time to completion. For real-time, we typically talk about 2 degrees. Real-time, usually in sub-seconds or seconds, and near real-time, seconds, minutes, or even hours. What is real-time analytics? Said as simply as possible. Real-time analytics is the ability to do something valuable with data as quickly as it's generated. For some use cases, real-time simply means that the analytics processing is completed within a few seconds or minutes after the arrival of new data. Gartner identifies 2 different types of real-time analytics. On-demand real-time analytics, that is, waits for the user or systems to request a query and then deliver the analytics result. Secondly, continuous real-time analytics is more proactive and alerts users or triggers responses as event happens. All organizations are collecting new data constantly. Creating insights from data is a must for organizations. All data and insights have a storage life or shelf life. If data sits unprocessed and not acted upon, the less valuable it becomes. For real-time applications, the value of data drops quickly as time passes. What the shelf life is, the time frame or deadline when data is no longer relevant, depends on the specific context and needs. Further, in order to be valuable to organizations, real-time analytical architecture must deal with 3 data attributes. Freshness, the delay until the data is available to act on. Latency, the sum of the data latency and the query latency. And then concurrency, the number of concurrent low latency access by data consumers. Streaming data describes continuous data ingestion, implying potential for decreased time to completion, but with no requirement on time to response. However, streaming data enables continuous propagation of data, transactions, and events in a data stream for real-time application and analytic. Stream processing often calls for multiple tasks on the data stream, which can be performed serially, in parallel, or both. Let's look at a typical processing flow. Left to right, the real-world event occurs. The event is captured at the source. At number 3, event propagation through a messaging system like Kafka. The event is then executed in a pipeline process, often including pre-processing, analysis, and then outcome. The result of the process is shared to data consumers, which acts on the results in either human-machine interactions, in a front end, using analytics tools, mobile apps, applications, or automated system-to-system integrations. Let's now look at good practice for analytics on data in motion. Handle everything as a source for events, including database transactions. Take an streaming-first approach for data ingestion. Analyze data in real time with streaming SQL. Move data at scale with low latency, and move data as little as possible. That is, push down when possible. Optimizing data flows by using real-time streaming data for more than one purpose and publish to multiple targets. Okay, example of flow. Is it fast enough? Let's check. Envision the following requirements. The analytics application should propagate events on the dashboard within a maximum deadline of 2.5 seconds after the real-world event occurred. So at zero time of event happened. At 03 seconds, event is transferred through a messaging system. The messaging processing pipeline completed after 1.5 seconds, followed by the result is available to consumers. Then the result is visible on the dashboard. Okay, we made it. Before we proceed into the Oracle Data Platform, let's look briefly at difference between micro-batch processing versus streaming process to assess the appropriate data mining strategy. Let's revisit the shelf life of data. When should the insight process, the analysis processing, be refreshed with new data? Staying current with data sources is a fundamental challenge. So it's important to choose the right model for the data refresh policy. Micro-batching is batch processing, but it's about splitting the data into a series of small independent tasks that allows to take advantage of parallel processing. A micro-batch can be processed in time intervals, that is, load and process data after interval time, or custom triggers. Load data by custom triggers, for example, batch data exceeds size limit or batch contains more than X number of entries of data. How to then to select approach for data ingestion and data processing? So if there's a need to be on seconds level that is close to real time, the choice is streaming. If you have requirements of near real time in minutes, then the choice is between either streaming or micro batching. When having requirements for not real time, then it's traditional batch processing with ingestion and data movement. Transform your real-time data into actionable insights. Get more and do more with your data. A modern data platform is a key to achieve business outcomes, which are a paradigm shifter and a need of time for many businesses to grow revenue. These are use cases that we see our customer across different industries aspire to do. Data-driven use cases by organizations spanning from telecom, finance, utilities, manufacturing, transportation, retail, and healthcare. We see a trend of great examples of how to convert real-time data into real tangible business outcomes. Now let's look at how the Oracle modern data platform support business insights and knowledge using real-time data. Oracle Modern Data Platform is an open platform with fully featured cloud-native service stitched together. If your system of records comprise of SaaS applications or ER applications on-prem or IoT sensor data, social media feeds, or any third-party application, all of that data can be collected, processed, and analyzed on OCI. The system of engagements will enable your data engineers to collect and process your real-time data as well as batch data into your data processing and data lakehouse services. Next comes your system of intelligence, where we have advanced analytics, AI, ML services. However, you can use any of third-party analytics, AI, ML tools, and notebooks of your choice. Enable your developers to develop cloud-native, data-driven applications using your existing developer platform and DevOps practices. We help you generate key insights from your data, do predictive and prescriptive analytics, and build your own data products or trigger actions into your system of records based on insights. Oracle Data Platform. Let's highlight capabilities and services for real-time data movement, processing, and analytics. Let's start with ingest and transform capabilities. When ingesting and transforming real-time data, there are a few capabilities you need to evaluate for determining the best ingest and transformation method. These capabilities include data latency, Data formats, structured, semi-structured, or unstructured. The data sources could be relational, files, non-relational, IoT logs, and clickstreams. And then protocols available and connectivity options. So change data capture. Using Golden Gate moves data in real time at scale. Golden Gate processes data as it moves from one or more data management system to target database or streams. Oracle Data Integrator works well as a partner with Oracle Golden Gate for complex data transformations. Streaming ingest. Oracle Streaming Service is a Kafka-compatible real-time event streaming platform for data, tightly integrated with Oracle databases, Golden Gate and OCI services included Oracle integration. OCI queues use open standards like STOMP and Open API REST endpoints to handle high-volume transaction data that requires independent process without loss or duplication. The OCI Service Connector Hub provides a central place for executing data movements between OCI services, such as object storage and streaming. Streaming processing. Set of services supporting streaming processing. Golden Gate and OCI Golden Gate Stream Analytics to model, process, analyze, and act on real-time streaming information by using correlation pattern, time series analytics, geospatial analytics, and machine learning. OCI data flow, run Spark streaming jobs on continuously streaming data, a fully managed automated service for Spark applications. OCI Big Data Service for Hadoop real-time streaming and data processing on Hadoop cluster, a fully managed automated cloud service for Hadoop environments. Then moving into OCI functions and service connector hub, building lightweight data processing and building event-driven applications from continuous data in OCI streaming. Looking then at capabilities and services for micro-batching. OCI Data Integrator, OCI Data Integration is an cloud-native ELT, extract, transform, load service that transforms and loads data into data warehouses and lakes on OCI. This service provides functionality for data ingestion and data preparation needed to support a data lake ecosystem. Data science can also utilize this service to simplify the data wrangling and feature engineering tasks. Oracle Data Integrator then as well can be used for batch processing that mature Oracle product, delivering performance and then for data transformation and validation. For application integration, Oracle Application Integration Cloud Service, connect to applications and data sources using Internet APIs. Then OCI Data Flow when running Spark batch processing for implementing high volume and repeating data jobs. Again, a fully managed automated service for Spark applications. Okay, moving to the persist create capabilities. The persistence layer is where data and results are stored for access. Depending on the context and use case, there are multiple stages that data may pass through from streaming to raw data, then to curated information. Note, some real-time data will remain only on streaming queues, other propagated into the raw data layer used by data science or in data pipeline processing, then persistent to a database. For storage, autonomous data warehouse for analytics on any data, autonomous transaction processing for mission-critical transaction processing, running Exadata for running databases with high performance and availability, MySQL for analytics and transaction processing, Oracle core databases, NoSQL database, and Oracle object storage as the de facto standard for data lakes. Analyze, predict, and learn. The access and interpretation platform includes visualization capabilities for analytics of both static and streaming data. In addition, the result of executed machine learning models are curated and exposed for analysis. Oracle Analytics Cloud provide a variety of options for intelligent analysis in an efficient way. Oracle Data Science Cloud for data science team to build, train, and manage machine learning models in Oracle Cloud Infrastructure. The data science service provides infrastructure and data science tools, such as open source technologies, libraries, and packages for machine learning and artificial intelligence. Oracle Machine Learning, Oracle moves algorithm to the data, executing machine learning with the database. This approach minimizes or eliminates data movements, preserves data security, and accelerates time to model deployment. AI service, ready to consume service for language, speech, document, vision, anomaly detection, and forecasting that simplify AI adoption for a wide variety of use cases. Then search service for open search, allow you to build in-application search that can return results in milliseconds, even with large data sets. Open search has many use cases, but it typically used for applications to search for large data sets and log analytics for insights. Data products apps. Oracle Kubernetes Engine and serverless functions for building real-time and event-driven applications at scale using events from streams, queues, database, and object storage. Executed on compute farm, optimized shape supporting your different performance requirements. Then using data products for API exposure, OCI API gateway, and REST data services. The API gateway service enables you to create governed interface for other services, including OCI functions, container engine for Kubernetes, for REST APIs for databases, and REST APIs for machine learning services. Okay, Oracle Data Platform provides established architecture patterns covering real-time transactions from any location, real-time transaction from ground to cloud, data availability across domains or regions, industry apps, data transactions, real-time transactions from messaging platforms, real-time ingest into data lakes, and then continuous data flows, big data processing, and real-time microtransaction applications. Okay, now let's look at 4 different real-world use cases using Oracle Data Platform real-time capabilities. Number 1, real-time predictions on manufacturing unit failure with enterprise asset management systems. Secondly, stream analytics for high-velocity sensor data, followed by real-time data streaming and image detection, and finally, real-time high-throughput event-driven application. Okay, let's start with use case number 1, the real-time prediction on manufacturing unit failure with enterprise asset management system. So, how can I manage my inventory in real time? How can I gain insight into supplier performance in real time? And how can I do this with fast time to value? This is the outcome that are delivered by this use case, by integrate real-time predictions on manufacturing unit failure with Oracle Enterprise Asset Management to manage assets and manufacturers. Now, let's explore the floor. Real-time events are ingested from manufacturing assets for prediction and probable failure processing. The OCI streaming service provides a Kafka-compatible event streaming platform for ingesting and consuming high-volume data streams in real time. So use OCI streaming for any use case in which data is produced and processed continuously and sequentially in a publish-subscribe messaging model. The uploaded asset events contains information like timestamp, asset ID, process temperature, rotation speed, and toolbar. The Service Connector Hub reads streams this data from OCI streaming. The Connector Hub triggers OCI function task for machine learning predictions. That is scoring of probable failure on asset data. The OCI function task writes scoring output to OCI object storage. In this use case, a custom machine learning model is used for prediction. A model that has been created and deployed through OCI data science, where the data science team train and deploy the model using open source tool. The data is then processed by a Spark application running on OCI data flow, a Spark streaming pipeline that process, aggregates, and persist scoring data to the autonomous data warehouse. This solution also integrates master data, asset inventory, and procurement data from enterprise asset management system into the autonomous data warehouse. Master data that is used for analytics in combination with the scoring result coming from the sensor data. The actionable insights provided by this use case are asset prediction to fail before executed end of life, for repurchase, and to identify badly performing manufacturers. Okay, before we jump to the next use case, let's revisit Spark Streaming integrated with reference data and machine learning applicable for both Golden Gate Stream Analytics, OCI data flow, and big data running Spark Streaming. So Spark Streaming with data from a streaming source or from an object storage if running a Spark batch model. The main stages are pre-processing, analysis, act, and deliver. Pre-processing covering tasks like filter, aggregate, transform, correlate, enrich, and geofencing. The analysis or prediction includes time window, data pattern, analytics, anonymities, classification, cluster statistics. Act is where you apply the business rules, the policies, conditional logic. And then actions is about publish, notify, evoke or execute, and visualize. For reference data, you can access large volume of reference data from autonomous data warehouse, autonomous database, or object storage. Then for machine learning, prepare data sets using feature engineering methods that can be used to build machine learning models, create a machine learning model, deploy this model for access, then build a Spark processing pipeline. In one of the stages of the pipeline, MS scoring would be a stage that integrates with the machine model in real time. When streaming data flows through the Spark pipeline, a Spark application would access this machine learning model through a service-oriented interface with data that needs to be scored. The service interface call would return the MS scoring result, and it would be used for the next stage of the data pipeline. Okay, let's head to the use case of streaming analytics for high velocity sensor data. The overall flow include capturing high volume of unique data points, continuously streamed from sensors, sensor information that include both complex and simple data. Once collected, the data is distributed to third-party media data server application and third-party real-time data management application for data pre-processing, where data is transformed from a proprietary format to a JSON format. The JSON data produced by applications are continuously published to Golden Gate Stream Analytics via OCI Streaming, which runs streaming pipelines. Golden Gate Stream Analytics enable users to identify events of interest by executing queries against event streams in real time. It provides real-time monitoring, transforming stream data, or raise alerts based on stream analytics. The result of the stream analytics is then sent to autonomous data warehouse. The real-time data management applications running on flexible compute shapes is used for both streaming data and batch processing of offloaded sensor data. In this scenario, batch data is ingested into object storage, then automatically loaded and into and processed in the autonomous data warehouse. Further, application transaction data persisted on the autonomous database are real-time replicated to the autonomous data warehouse using Golden Gate for database-to-database replication. And then finally, Oracle REST data service is used to expose data from the Oracle autonomous data warehouse to the different client data consumers. The use case of real-time data streaming and object identification using OCI Golden Gate, OCI Vision, and Oracle Autonomous Database. Multiple feeds are ingested into the solution. At its core are real-time data streaming from event producers into autonomous database using OCI Streaming and OCI Golden Gate. This use case performs real-time image identification using OCI Vision. OCI Vision is one of the several AI services available in OCI. OCI Vision gives you the power to apply machine learning and artificial intelligence without needing data science expertise. OCI Vision includes pre-built models available out of the box, which allow image recognition and text recognition to be built into your applications without prior machine learning expertise. But it can also be used with the data labeling service to create custom models for specific data you have. In this use case, the OCI Vision custom model has been trained using the labeled data set of objects to process. So the object identification process. The image producer upload image to OCI object storage. The OCI event is used to automate the image processing. When images are uploaded to object storage, the associated event triggers OCI functions. A request is sent to the serverless function to call the OCI Vision service. The created OCI Vision model is natively able to provide as output the metadata of each recognized object. The function then calls the autonomous database to store metadata for processed image objects. Further, the autonomous database runs Oracle machine learning models to bring out interesting insights from OCI Vision metadata and Golden Gate enabled real-time data. Finally, data consumers pull their required data using REST APIs written in OCI functions and exposed via API gateway. As this is an internet-facing service, the OCI web application firewall is used to provide layer 7 protection. Okay, the last use case to explore today is about real-time, high-throughput, event-driven application. This flow manage data events sent at different velocity from different data producers to event-driven microservices. The microservice architecture style is an approach to develop an application as a suite of small independently deployable services built around specific business capabilities. The Oracle Container Engine cluster connects with the OCI streaming service for receiving real-time events using the OCI service operator for Kubernetes. The publish, subscribe OCI streaming APIs provides decoupled communication, make it easy to add new listers, the data consumer service that is, or new publishers, the data producers, without disrupting existing processing. The microservices on the Kubernetes engine use OCI queue for asynchronous connectivity, where they publish and subscribe to the queue transparently. When you combine these messaging capabilities with the simple concept of microservice, you can greatly enhance the agility with which you build, deploy, and maintain complex data pipelines. Pipelines are constructed by simply chaining together multiple microservices, each of which listens for the arrival of some data, performs its designated task, and publish its result message, in this case to OCI OpenSearch. This use case also streams data to an autonomous database in real time, where the Service Connector Hub reads streaming data from OCI streaming, then triggers an OCI function task that will make inserts and updates to the autonomous database. And then finally, the end user search interface built on Apex or in Visual Builder are connected to OCI OpenSearch and to the autonomous database as the query-backed data source to return search results in milliseconds, even with large data sets. Okay, I will close this session with the evolution towards a data mesh with event streaming for real time. Now at 2023, IT infrastructures has dramatically changed. Networking, containers, cloud, compute, IoT, etc. are pushing data to the edge. A mature data processing architecture is not a single instance hub, but rather a distributed data mesh with event streaming for real time. An architecture enabled for data in motion, supporting stream data processing, change events, and time series data in the new multi-cloud era. Okay, let's all stay tuned for the future. With that, I want to thank you for watching this video. You find the links on page on how to engage with the EMEA Cloud Expert team. Take care now and goodbye.